tunnels. I will show you the fourth one. And this is what I found out, that as we look at the Sphinx today.
For thousands of years, it has sat in absolute silence beneath the Egyptian sun, its weathered face fixed on the eastern horizon long before the first pharaoh's name was ever carved into stone. Cut directly from a single ridge of limestone, the Great Sphinx is unlike anything else on Earth. 73 meters long, 20 meters tall, a monument so enormous that entire generations have lived and died in its shadow without ever settling the one question that matters most. Who built it? For most of the last century, the answer seemed closed. Recently, researchers pointed an artificial intelligence at the accumulated evidence, laser scans, geological surveys, satellite imagery, decades of archaeological measurement, and asked it to draw its own conclusions instead of repeating the textbook answer. What came back didn't confirm the story we've been told. It complicated it. The standard account is elegant and precise. Around 4,500 years ago, during Egypt's fourth dynasty, the Pharaoh Khafre, who reigned roughly from 2558 to 2532 BCE, ordered his workers to shape a leftover limestone outcrop from a nearby quarry into a guardian for his pyramid complex. The face is his. The body is a lion, the ancient symbol of royal power. Half man, half beast, it was built to stare down the rising sun for eternity. The supporting evidence is contextual rather than direct. The Sphinx sits inside Khafre's architectural complex, a stela erected by Thutmose IV around 1401 BCE, placed between the Sphinx's paws after the pharaoh claimed the monument had appeared to him in a dream, calls it the image of a solar deity. Mark Lehner, founder of the Ancient Egypt Research Associates, spent over a decade excavating at Giza and concluded the surrounding archaeological context strongly supported a fourth dynasty date. A workforce with copper chisels and wooden mallets, roughly 2,500 BCE, case closed, or so it seemed. There's one detail that account has never fully explained: water. Look closely at the Sphinx's body and the walls of the deep pit carved around it to free it from the bedrock. The limestone isn't weathered the way a geologist would expect from a structure that has spent its entire existence in a desert. Wind-driven sand produces a rough, pitted, horizontally scoured texture. Salt crystallization causes a different kind of decay, a crumbling, pockmarked surface where crystals grow inside the stone's pores and fracture it from within. What the enclosure walls actually show is neither. They show deep, rounded, vertical channels, wide near the top, deepening as they descend, exactly the profile left by sustained rainfall running down a stone face over centuries, not a single flood or flash event. French scholar René Schwaller de Lubitsch first raised this publicly in 1961. Researcher John Anthony West later developed it into a formal geological argument. It reached the scientific mainstream in 1991 when Boston University geologist Robert Schoch presented his findings to the Geological Society of America, having personally examined the enclosure walls and compared their erosion profile against known weathering signatures. His conclusion: the dominant force shaping that stone was precipitation, the kind of sustained heavy rainfall the Giza Plateau hasn't experienced in any meaningful quantity since roughly 5,000 BCE. Egypt has been a desert for a long time. The Green Sahara, the era when North Africa supported grasslands, lakes, and rivers, wound down by around 3,500 BCE, with the heaviest rains tapering off even earlier than that. rainfall capable of carving those grooves into limestone that dense hasn't fallen on the Giza Plateau since long before Khafre was born. If the Sphinx were only 4,500 years old, its body should carry the marks of the climate it actually lived through. It doesn't. It carries the fingerprint of a wetter world, which means, if Shok is right, the monument had to already be standing while those ancient rains were still falling. For decades, that was the stalemate. Shok pointing at the watermarks, mainstream Egyptologists like Lehner and Zehi Hawass pointing at the archaeological context surrounding Khafre's complex. Neither side able to move the other. That's the deadlock researchers decided to approach differently, by handing the raw data to Grok, the AI system built by Elon Musk's XAI, rather than to another human scholar who would arrive already carrying a preferred answer. A machine has no career invested in the outcome, no grant to protect, no decades of publications that would need quiet revision if the evidence pointed somewhere uncomfortable. It arrives holding nothing, so they gave it everything. Every erosion survey ever conducted on the enclosure, laser scans of the body and trench walls, 40,000 years of Eastern Sahara paleoclimate reconstruction drawn from Nile sediment cores and ancient lakebed pollen analysis, limestone weathering rates under sustained precipitation, and the 1992 seismic survey by Thomas Dubecki and Robert Schoch that detected anomalous subsurface cavities beneath the monument. No instructions on which theory to defend, just the measurements, with a request to report what they actually showed. Grok treated the weathering as geometry rather than impression. The depth of every groove, the curvature of every ridge, the vertical spacing of every undulation, cross-referenced against the known signatures of wind, salt, and rain erosion. Its output put rainfall erosion at 94.7% confidence. The wind and sand explanation the traditional account relies on came back a fraction of that, not impossible, just statistically overwhelmed by the evidence. A confidence score alone isn't a conclusion, though, so the analysis pushed further. How long would it take rainfall at Green Sahara intensity to cut grooves of that specific depth into limestone of that specific hardness? Running the erosion depth against known rainfall models placed the required exposure at many centuries minimum, meaning the Sphinx would have had to be standing before roughly 7,000 years before Khafre's birth to accumulate that pattern. As one engineer reviewing the output put it, the stone was behaving like a witness. It didn't know what story it was supposed to tell. It simply recorded what happened to it, one rainy season at a time, and that record doesn't match the accepted timeline. Anyone who stood in front of the Sphinx has probably felt something faintly off about it without being able to name it. The body is a sprawling, reclining lion, filling an enclosure the size of a city block. The head perched atop it looks almost too small, as if borrowed from a different sculpture entirely. Grok tested that impression by measuring the proportional relationship between the head and body, against what any sculptor working from a single unified vision would maintain. The numbers didn't come close. For the current head to be in correct anatomical proportion with the body, it would need to be several times larger than it actually is, raising an uncomfortable possibility. The head on the Sphinx today may not be the original. Schoch proposed exactly this in later work, suggesting the human face was carved during the Old Kingdom as a reworking of an earlier, more weathered form, and its comparatively poor preservation reflects that it was recarved from an already degraded block, not freshly cut from raw stone. The weathering supports the theory. The flanks and enclosure walls carry the rounded rainfall channels of a wet, ancient climate, while the head shows a sharper, drier profile, the wear of wind-blown sand over a much later, arid age. Two different climates touched two different parts of the same monument, which only makes sense if they were shaped in two different eras. When Grok modeled what the original, correctly scaled head would have looked like, the reconstruction wasn't human. It was leonine, a lion, complete, from nose to tail. Hold that image, because the analysis then asked a question no formal study had fully completed. When would a lion-shaped monument have made astronomical sense? Not artistically, but literally. The Sphinx faces due east, aligned to the exact point on the horizon where the sun rises on the spring equinox, confirmed by multiple independent calculations to the arc minute. Earth's axis wobbles slowly over roughly 25,920 years, the precession of the equinoxes, shifting which constellation sits behind the rising sun by about 1 degree every 72 years, with each zodiacal sign occupying that position for roughly 2,160 years. Running the sky backward, Grok tracked when the constellation Leo would have risen with the equinox sun directly on the Sphinx's sightline. The window, roughly 10,500 to 8,000 years before the present. The astronomical age of Leo. Graham Hancock and Robert Bauval proposed the same connection in their 1996 book, The Message of the Sphinx. The machine, working independently from raw astronomical data, arrived at essentially the same calculation. A lion on the ground, staring at a lion in the sky, locked to an astronomical window that closed thousands of years before the first pharaoh was born. As one astronomer reviewing the figures noted, the alignment is too clean to be coincidence. The odds of a randomly oriented monument happening to face its own zodiacal symbol during its own celestial age are, effectively, zero. A marker only matters if it points at something, so the analysis turned outward. Beneath the Sphinx's paws, that 1992 seismic survey had already flagged a chamber-shaped void roughly 9 by 12 meters, sitting almost exactly on the equinox axis line, as if something the Sphinx was watching on the horizon had a mirror buried directly beneath it, widening the search across other ancient monuments known for precise solar or stellar alignment. Göbekli Tepe in Turkey, dated to roughly 9,500 to 8,000 BCE, and predating Stonehenge by more than 6,000 years. Sacsayhuaman in Peru, where multi-ton polygonal stones interlock without mortar to tolerances modern engineers still struggle to explain. Stonehenge itself, its bluestones hauled roughly 240 miles from Wales. Grok measured the angular relationships between sites and found repeating proportions rather than random scatter, as though each had been positioned against a shared underlying reference no surviving civilization has ever documented. The strangest finding came last. Ranking every site by construction precision, flatness, joint tolerance, alignment accuracy, researchers expected the pattern every history of human skill assumes: rough beginnings sharpened over generations into mastery. The data ran the other way. The oldest structures in the network were the most precise. The oldest joints, the tightest. The oldest alignments, the most exact, with quality degrading as centuries moved forward, angles drifting, once flush stones needing fill, once perfect alignments beginning to wander. The knowledge wasn't accumulating. It was eroding, each generation inheriting a little less of the original understanding, copying the shape of what came before without fully grasping the mathematics behind it. If that reading holds, the Sphinx and the network it may anchor aren't the dawn of civilization. They're its last competent echo, work produced by knowledge already in decline, preserved in stone precisely because stone is what outlasts the people who carved it. The dates keep circling back to roughly 12,000 years ago, and the Younger Dryas, one of the most abrupt climate reversals in the last 100,000 years, when Northern Hemisphere temperatures collapsed within decades, and North American megafauna vanished in a geological instant. A hypothesis published by Richard Firestone and colleagues in the Proceedings of the National Academy of Sciences in 2007 points to a possible comet or asteroid trigger, citing nanodiamonds, shocked quartz, and cosmic spherules found at that exact boundary across North America and Europe. A 2018 Journal of Geology study identified the largest platinum anomaly ever recorded in an ice core at the same layer. Whatever caused it, it was the kind of event that ends a world, and the monuments in this proposed network cluster on the far side of it, beginning to appear in the record around 10,000 to 9,500 BCE after the ice let go again. In the roughly 12,000 years since, sea levels have risen about 120 meters, swallowing the coastal margins where the overwhelming majority of ancient populations always lived. Whatever evidence a pre-Younger Dryas culture left behind on those coastlines now sits beneath the ocean floor, out of archaeology's reach. What remains are the survivors, built high enough and durable enough to outlast the flood. That's the one question the analysis couldn't answer. Grok found the structure of a message, geometry, alignment, a network spanning continents, without being able to read its content. It identified where the message points without knowing what it says. The Sphinx is still out there in the desert, watching the same horizon it's watched since before the first pharaoh drew breath. It never changed. It was never hiding anything. We simply lacked the tools to read it until we built tools capable of listening and finally pointed them at the stone. It's worth being precise about what this analysis actually is, because the temptation with a story like this is to round it up into certainty. It isn't proof. A confidence score of 94.7% on an erosion model is a statistical statement about pattern matching against known weathering profiles, not a carbon date, not a signed confession from a Bronze Age quarry crew. Grok didn't excavate anything. It didn't carbon date a single grain of sand. What it did was take decades of measurements that mainstream Egyptology has never fully reconciled. Shocks, rainfall geology, the head-to-body ratio, the precession alignment, and run them through the same evidence simultaneously, without the institutional pressure to make them fit a predetermined date. That's precisely why the result is uncomfortable rather than simply exciting. Mark Lehner's Fourth Dynasty dating isn't a lazy guess. It's built on genuine, extensive fieldwork, tying the Sphinx physically into Khafre's complex. Shok's water erosion argument isn't fringe speculation either. It survived peer review at the Geological Society of America over 3 decades ago and has never been definitively refuted on geological grounds, only argued around. What's new isn't the evidence. It's having something ask all of it the same question at once, with no professional stake in which answer wins. That doesn't settle the debate. If anything, it sharpens it. Either the erosion signature has some explanation nobody has yet proposed that doesn't require pushing the Sphinx back 7,000 years, entirely possible, and exactly the kind of challenge a rigorous geologist would want thrown at Shok's model, or a piece of the story we've told ourselves about the birth of civilization is missing an earlier chapter. The Sphinx is still out there in the desert, watching the same horizon it's watched since before the first pharaoh drew breath. It never changed. It was never hiding anything. We simply lacked the tools to read it, until we built tools capable of listening and finally pointed them at the stone. So, here's the question worth sitting with. If the Sphinx was built to face the dawn of the Age of Leo, a clock set running for 10,000 years, what was it counting toward? A memorial for what was lost, or a warning about what hasn't happened yet?